Welcome to BMAC.MATH tutorial. Subscribe our channel and hit the bell icon for freshly uploaded content. This is a problem from CSIR NET December 2019. This problem belongs to part C with marks 4.75. Therefore, there may be multiple options be true. Here we are given a quadrature formula and it is asked to find some values of constants, and for which the given quadrature formula is exact for the polynomial of highest possible degree. We know that the nodal points of a quadrature formula is given by the roots of the legendary polynomial, say Pnx is equal to 2 to the power 1 by 2 to the power n factorial d to the power n dx to the power n x square minus 1 to the power n. Here we are given a 3-point quadrature rule, hence the values of n is 3, therefore p3 x is equal to 1 by 2 to the power 3 into 3 factorial d cube by dx cube, this x square minus 1 cube. On simplifications we have this is equal to 1 by 48 and d cube dx cube x to the power 6 minus 3x to the power 4 plus 3x square minus 1. On differentiation 3 times we have this is equal to 5x cube minus 3x. Now the nodal points are given by the roots of p3, hence p3x, if we set p3x is equal to 0, then we have 5x cube minus 3x, this is equal to 0, and if we take common x we have 5x square minus 3 equal to 0, and x is equal to 0, x is equal to square root of 3 by 5 plus minus. Hence the values of alpha becomes square root of 3 by 5, and the nodal points are minus the nodal points are minus alpha is equal to minus square root of 3 by 5 0, and alpha is equal to square root of 3 by 5. Now since the quadrature formula is prescribed at the 3 points, therefore it gives exact result for fx is equal to 1 and fx is equal to x and fx is equal to x square. If we put let fx is equal to 1, then from the quadrature rule minus 1 to 1, say fx into 1 minus x dx is equal to a f of minus alpha plus b into f of 0 plus c into f of alpha. If we put fx is equal to 1, then minus 1 to 1 1 minus x dx, this is equal to a, since fx is equal to 1, f of minus alpha this is equal to 1, and f of 0 is equal to also 1, and c f of alpha is equal to also 1. Therefore we have a plus b plus c is equal to x minus x square by 2 minus 1 to 1, this is equal to 1. This implies a plus, this we have a plus b plus c is equal to 2. Let us denote this equation by equation 1. Now if we put fx is equal to x, then from the quadrature formula we have minus 1 to 1 x into 1 minus x dx is equal to a of minus alpha plus b into 0 plus c into alpha. This implies minus 1 to 1 x minus x square dx is equal to minus alpha into a plus alpha into c. This implies x square by 2 minus x cube by 3 minus 1 to 1 minus alpha a plus alpha c. This implies minus alpha a plus alpha c is equal to minus 2 by 3. Let us denote these equations by equation 2. Again put fx is equal to x square, then minus 1 to integration minus 1 to 1 x square into 1 minus x dx is equal to alpha a alpha square plus b into 0 plus c into alpha square. This is equal to minus 1 integration minus 1 to 1 x square minus x cube to dx equal to alpha square a plus alpha square c. This is equal to x cube by 3 minus x to the power 4 by 4 integral minus 1 to 1 is equal to alpha square plus alpha square into c. This implies alpha square a plus alpha square c. This is equal to 2 by 3. Let us denote this equation by equation 3. Thus we obtain a plus b plus c is equal to 2 and a minus c is equal to 2 by 3 alpha and a plus c is equal to 2 by 3 alpha square. This is equation 4. Let us denote this by 5 and let us denote this equation by 6. Now equation 5 plus equation 6 gives 2a is equal to 2/3 1 plus alpha plus 1 by alpha square. This which implies a is equals 1 by 3 1 by alpha plus 1 by alpha square. This is equal to 1 by 3. Since alpha is equal to square root of 3 by 5, since alpha is equal to square root of 3 by 5, therefore 1 by alpha is equal to square root of 5 by square root of 3 and 1 by alpha square is equal to alpha square is equal to square root of 1 by alpha square is equal to 5 by 3. Hence a is equal to 5 by 9 plus square root of 5 plus 3 root 3. If we take common 5 by 9, then we have 1 plus 9 by 5 square root of 5 by 3 root 3, which is equal to 5 by 9 1 plus root 3 by root 5. And now 6, subtracting equation 5 from 6 gives 2c is equal to 2 by 3 1 by alpha square minus 1 by alpha. This implies c is equal to 1 by alpha square 1/3 1 by alpha square minus 1 by alpha is equal to 1 by 3 5 by 3 minus square root of 5 by 3 square root of 3. This is equal to 5 by 9 minus square root of 5 by 3 root 3. This is equal to, if we take 5 by 9 common, then 1 minus 9 by 5 square root of 5 by 3 root 3, which is equal to 5 by 9 1 minus square root of 3 by square root of 5. Now from equation 4 we have b is equal to 2 minus a plus c. This is equal to 2 minus a plus c is equal to 2 by 3 alpha square from 6. This is equal to 2 1 minus 1 by 3 alpha square is equal to 2 1 minus 1/3. Now 1 by alpha square is equal to 5 by 3. This is equal to 2 1 minus 5 by 9. Now this is equal to 2 into 4 by 9 8 by, which is equal to 8 by 9. Hence we found thus alpha is equal to square root of 3 by 5, a is equal to 5 by 9 plus square root of 5 by 3 root 3, which is also in another form 5 by 9 1 plus root 3 by root 5. b is equal to 8 by 9 and c is equal to 5 by 9 minus square root of 5 by 3 root 3, which is also is equal to 5 by 9 1 minus root 3 by root 5. Hence the option 1 and 4 are